A very good morning to all the teachers and my dear students. I am Priyanka Sapkal from Goregaon MPS Municipal Secondary School East. So today we are going to discuss few of the question and answers of carbon compounds. So let's start with our session. Now students, first of all we will go from the few of the scientific reasons, few of the definitions and few of the question and answers. One by one we will see. So now many of the questions are asked. Some of them are like that due to dash vegetable oil is converted into vanaspati ghee. Now in MCQs, four options will be given to you and you have to write one of them. Okay, so here first question is due to the dash comma vegetable oil is converted into the vanaspati ghee. Now here different types of reactions are given to you: hydrogenation, dehydration, chlorination or polymerization. From which of the following reactions this vegetable oil is converted into the vanaspati ghee? So then for that, hydrogenation is the process of converting the vegetable oil to vanaspati ghee. So here during the hydrogenation, vegetable oils are reacted with hydrogen gas at about 60 degrees centigrade. So a nickel catalyst is used to speed up the reaction. So here the double bonds are converted into the single bond in the reaction. Now students, as you know that whenever there is a double bond, in double bond number of hydrogen atoms are less, so that's why double bonds are formed. Okay, so in that case, whenever you do the process of hydrogenation, that means you are adding the hydrogen. So when you will add the hydrogen, then in that case, whatever the bonds are, the extra bonds are there or the double bonds or triple bonds are there, they will be removed and it will be converted into a saturated hydrocarbon. That means we are converting an unsaturated hydrocarbon to a saturated hydrocarbon by adding hydrogen. So here in this case, the answer of the first MCQ is hydrogenation. Then comes the second one. Dash is used to prepare the carbon black. Now, carbon black, as you might have known that what do you mean by the carbon black? So here in this case, whenever there is an incomplete combustion of methane, okay, then methane is CH4, so it yields the carbon black, which is widely used as a reinforcing agent in rubber, which is used for the automobile tires. So here in this case, the answer for this question is methane. So methane is used to prepare the carbon black. Then comes dash is the general formula of alkene. Now here dash is the general formula for the alkene. So alkene has the formula as you can see here. This is the chart where it shows the structures, different saturations, unsaturations, general formula, type of bonding, naming and simple structures. So here as the question is, what is the general formula for alkene? Now whenever it comes alkenes, then the second one, that is alkene, is having the general formula of CnH2n. Okay, so here in this case, carbon-carbon has a double bond and it is an unsaturated. In this case, there is an unsaturated carbon atom presence, okay, which do not hold the highest allowed amount of hydrogen atoms. So here the answer will be CnH2n, that is the A option. Then comes the reaction of a methane with chlorine in presence of sunlight. Now what will be the reaction of methane, that is CH4, in presence of chlorine when there is sunlight is present? So different types of reactions are given to you: pyrolysis, elimination reaction, substitution reaction and addition reaction. Now first of all, you should know the meaning of all these reactions. Okay. Now elimination means whenever you eliminate some atoms. Substitution means replacement reaction. That means whenever you replace the atoms or the molecules. So afterwards comes the addition reaction. Addition means you have to add something over there. Okay. And pyrolysis. Now see. Here in this case, okay, when a mixture of methane and chlorine is exposed to sunlight, in that case, what happens? A substitution reaction occurs and the organic product is chloromethane. Then that also undergoes few of the substitution reaction. After that, we can get dichloromethane, trichloromethane or tetrachloromethane. So here you can see CH4Cl2, that is CH3Cl. Okay, that means one of the hydrogen from CH4 is removed and one of the chlorine from Cl2 is removed, and that hydrogen and chlorine will form HCl, that is hydrochloric acid. And then what we will get? We will get chloromethane, that means CH3Cl. Then again from that chloromethane, if again it is get reacted with the chlorine, in that case again one of the hydrogen from the CH3Cl will be removed and one of the chlorine from the Cl2 will be removed, and then afterwards what will happen? HCl and CH2Cl, that is dichloro, that as two chlorines are present, that's why dichloromethane will be formed. Then again if it undergoes chlorination or the substitution with the help of chlorine, so in that case again same trichloromethane will be formed. That means likewise each one by one step we are removing the hydrogen atom, and in that hydrogen atom, in that place of hydrogen atom we are placing chlorine. So likewise one by one chlorine is added and at last we are getting tetrachloromethane. Okay, where 4 number of chlorine atoms are present. So here in this case the answer will be the substitution reaction. Then comes the general formula for alkynes. Okay, so what is the general formula for alkynes? As here I already shown you that the general formula for alkanes is CnH2n plus 2. The general formula for alkenes is CnH2n. The general formula for alkynes is CnHn. Or you can also write it as CnH2n minus 2. This is also you can write for the alkynes. So here in this case, CnH2n minus 2, that is C option will be correct. Okay. Then comes ethylene has dash bond between two carbon atoms. Now here in the alkenes, in the structure of alkenes, you can see the simple structure for the alkenes. There it is written that C double bond C and 2 hydrogen each carbon atom is containing. Now the name is ethylene. Now here in this is ethylene, and where double bond is present between the carbon and carbon. So here the answer will be a double, that is B option will be there. Ethylene has a double bond between the 2 carbon atoms. Okay. Next question is the organic compound having double or triple bond in them is termed as saturated, stable compound, volatile compound or unsaturated compound. Now students, as we had seen in hydrocarbons, saturation, whenever alkene contains single bond, then that hydrocarbon is known as the saturated hydrocarbon. And whenever alkenes and alkynes, okay, both the alkenes and the alkynes, they contain a double or a triple bond. In that case, that is known as the unsaturated hydrocarbon. That means if single bond is present, then that is a saturated hydrocarbon. But if double bond or triple bond is present, that is an unsaturated hydrocarbon. That means we can say that all the alkanes family, they contain a single bond, and that's why they are saturated hydrocarbon. Whereas the families of the alkenes and the alkynes, they contain a double or a triple bond. So that's why they are known as the unsaturated hydrocarbon. So here the organic compound having a double or triple bond in them is known as the unsaturated compounds. The option is D. Okay, then comes next question. C7H16 is a hexane, a octane, a methane or a heptane. Now, first of all, you can see in all the option, whatever name is given to you, in that ANE is there. That is AN is for alkane. Okay. This is the suffix for the alkene, A and E. Okay. Then how many number of carbons are present? 7 number. Whenever there is a 7 number is present, then in the previous lectures we had studied that whenever 7 number of carbon is present, that we consider, for that case we consider the root word as hept. So here hept plus all contains ane, that means all are the alkenes. So here we can say the name will be heptane. Okay, so here I can show you alkanes. Now in alkanes ane is there and the formula is CnH2n plus 2. So if the number of carbon is 7, that is C7, then H 2 into 7, 14, 14 plus 2 will come 16. That means here C7H16 will be the formula for the alkanes, that is heptane. You can see here in hydrocarbons alkanes. The second last one is the heptane, where you can count the number of carbon, where 7 number of carbons are present and 16 number of hydrogens are present. So this is the picture for the heptane. Okay, next comes one formula is given to you. Bond C double bond O, again single bond OH is called as. Now this group is known as the COOH group. Okay, and whenever this COOH group is present, that means that is a carboxylic acidic group. Then if now here 4 options are given to you and you should know the formula for each and every option, so that it will be easier for you to understand what will be the answer. For carboxylic group, the formula is COOH. Then for aldehydic group, the formula is CHO. For ketonic group, it is C double bond O, and for alcoholic group, it is OH. So here, as we had learned also common functional groups in the organic compounds, and these are the functional groups. You can see alkene, alkyne, alcohol. For alcohol, OH group is present. For ether, C single bond O and again bond C. That means O is the main functional group. Then for haloalkanes, that means halogen will be considered as X. Then CN means amine. Then CHO is aldehyde. Ketone has C double bond O and carboxylic group has COOH group. Okay, so here in this case the answer will be carboxylic acid group, that is the A option. Okay, next comes oxygen molecule has dash bonds between 2 oxygen atoms. Okay, whenever the oxygen, how many numbers of bonds will be present between the 2 oxygen atoms? There will be a double bond, single bond, triple bond or an ionic bond. So here in this case from your textbook, this picture is there that we had studied that hydrogen contains single bond, oxygen contains double bond and nitrogen contains triple bond. So depending upon the valency which is present, now as the valency of oxygen is 2 because it requires 2 more electrons to complete its octet, so that's why they form a double bond with itself, okay, with the same atom, that is oxygen. So here that's why oxygen forms double bond. Okay, then for nitrogen also it forms a triple bond, that is nitrogen contains triple bond between them. Hydrogen contains single bond and oxygen contains double bond. So here the option will be oxygen molecule has double bond between the 2 oxygen atoms. The reaction of dash with ethanol is a fast reaction. Now the reaction of dash, okay, what will be the reaction of a certain compound with ethanol which will you can say make the reaction fast? It will be either from calcium with magnesium, sodium or aluminum. Now here in this case ethanol reacts very slow with methyl iodide. Okay, so to give the methyl ethyl ether, but sodium ethoxide, that means sodium, whenever sodium reacts with ethanol or sodium ethoxide reacts with ethanol, the solution reacts it quite rapidly. Okay, the reaction takes place very rapidly, and in fact the reaction of the alkoxide with alkyl halide or alkyl sulfates is an important general method for the preparation of the ethers. So, and that's why it is known as the Williamson synthesis. Okay, then Next question. The molecular formula of acetic acid, okay, that is ethanoic acid is. Now, whenever the word comes eth means what? If meth is there, then only one carbon will be present. If eth root word will be there, that means ETH. That means that particular compound should contain two carbon atoms. Now, from the four option given below, you can find out the compound containing two carbon atoms. Okay, eth means two. Then after that, noic acid or oic acid is there. So acid word is present. That means here carboxylic group should be present. That is COOH group should be present. Now COOH group is present in all the options. Now from the root word, that is from the eth word, we can find as eth means two carbon. So the option which contains two carbon will be the correct option. So here in option A, only one carbon is present. Option B, you can see two carbon. Option 3, option C, you can see there are three carbons are present. In option D, there are four carbons present. That means our correct answer will be B, that is CH3COOH. It is known as the acetic acid or ethanoic acid. Then comes the name the carbon compound of the following structure. Now, students, this is the structure for the benzene. Okay, so here in this case, you can click the photo also that this is the structure for the benzene. C double bond, single bond, again double bond, single bond, double bond, single bond. Likewise, alternate double and single bonds are present, and with each carbon, one hydrogen will be present. Okay, the reaction of vegetable oil with bromine is dash reaction. Okay, which type of reaction is it? Is it a addition reaction? Is it a displacement reaction, a double displacement, or a combination? So here we can see the explanation for it. The reaction of bromine water with vegetable oil is an addition reaction. What happens here in the reaction of bromine water with vegetable oil? The bromine molecule is adding to the double bond of vegetable oil, forming a single product. So here, vegetable oil, it is an unsaturated fatty acid, which means that they have double bond in the structure. So the reaction of bromine with unsaturated compound is known as the bromine water test. So addition reaction is what? It is a type of reaction in which two or more reactants they combine to form a single product. So in the reaction of bromine water and vegetable oil, bromine molecule is added to the double bond of the vegetable oil, forming a single product. So the image shows the addition of the bromine water in vegetable oil. So here the answer will be the addition reaction. Okay. So some acetic acid is treated with NaHCO3, that is the sodium bicarbonate. So the resulting solution will be, what will be the resulting solution here? In this case, the resulting solution will be colorless. So the option will be A. So when sodium bicarbonate is added to dilute ethanoic acid, what will it form? Ethanoic acid means CH3COOH and sodium bicarbonate means NaHCO3. So in this case, when these two react with each other, what will happen in this case? A gas is evolved. The gas will be evolved, and hence the option will be a gas evolved. Then when ethanoic acid reacts with ethanol in presence of acid, catalyst dash ester is produced. So which ester will be produced when ethanoic acid and ethanol both will be reacting? Okay, so in this case, the answer is ethyl ethanol. Okay, so here ethyl ethanoate will be formed. Then comes the correlation. Now here alkene, and it is not C triple bond, it should be C double bond C. Okay, so when alkene and the relation of the alkene is C double bond C, and for alkyne it will be C triple bond C. Okay, then comes the methane. Now likewise relationship can also be asked to you. So if methane has the structure of CH4, that means it contains single bond, and as it contains single bond, that's why it is a saturated hydrocarbon. Same we have to write for the propene. Now propene is there, ENE is there, that means it is an unsaturated hydrocarbon containing double bond. Okay, so here the correlation will be the unsaturated hydrocarbon. Okay, then comes the match the columns. Now in column 1 and column 2 are given to you. So from column 1, 2 questions are asked, and in column 2, 4 options are given to you. You have to select the right one. Okay. Now aromatic hydrocarbon. Now whenever there is a cyclic structure, okay, that contains an, that is from the aromatic family, you can see. A closed ring structure is there, that is an aromatic hydrocarbon. So here from the option given to you A, B, C, D. Now benzene has a closed structure. So we can easily write that aromatic hydrocarbon, and hydrocarbon means containing hydrogen and carbon. So here in this case aromatic hydrocarbons are benzene. Then comes the alkane. Now alkane is having the alkane means ANE, that is containing the single bond. Okay. Now it contains single bond and the formula is CnH2n plus 2. Now alkane, propyne is not an alkane because YN is there and it is the family from the alkyne group. Benzene we consider for the aromatic hydrocarbon. The saturated hydrocarbon, it can be for the alkane, and CnH2n is not the formula for the alkane. So the correct option is saturated hydrocarbon containing single bond. Then comes the next column. When two functional groups are given to you, OH and COH, you have to write the names of them. OH is an alcoholic group, as we had studied, and COH group is a carboxylic acid group. So you have to learn what is the formula for each of the functional. What is the formula for the functional groups? Okay, likewise for aldehyde, there is a CHO group. For ketone, C double bond O group is there. Okay, so that will be easier for you to recognize. Then comes the fourth one, that is ethyne and ethene. Now, whenever ethyne is present, that means it is an alkyne. Okay, eth means carbon containing two number of carbons are there. So one of the formula we had seen that CnHn for the alkyne group. That means whatever the number of carbon will be there, that will be the number of hydrogen. So here in this case, ethyne will go with option B, that is C2H2. Then comes the ethene, and ethene it goes for the formula of CnH2n. Okay, so in that case, eth means 2 carbon, so 2 carbon and hydrogen 2n. So 2n means 2 into 2. So here 4 hydrogen will be there. That means number of carbon will be 2 and hydrogen will be 4. So we will go with the option D for the ethene. Okay, so likewise, match the columns can be asked to you. If you had studied well, then you can easily able to answer. Then comes the true and false. A few of the true and false can also be asked to you. So likewise, few of the questions we will see. Unsaturated hydrocarbons are less reactive than the saturated hydrocarbons. So as we know that the unsaturated hydrocarbons, they are not less reactive, even they are also more reactive. Okay, so it is not less reactive than the saturated hydrocarbons, so hence we can say that this statement is false statement. Okay, then comes the benzene is an aromatic compound. Yes, it is true, because we had already seen in the match the column also, it is an aromatic hydrocarbon. Whatever the cyclic groups, the closed chain structures are there, okay, having alternate double and single bonds, they are all aromatic compounds. Then comes the naphthalene burns with a yellow flame. It is also true, naphthalene burns with a yellow flame. Now this statement is asked for the scientific reason also, and that we will see further. Okay, so when vegetable oil and tincture iodine react, the color of the iodine does not change. Okay, now in this case the color changes, so that's why we can say that this statement is a false statement. Okay, then fifth one is, a saturated fats are healthy. So obviously not, saturated fats are not healthy. Okay, so then hence this statement is a false statement. Then comes the vinegar is a 12 to 15% aqueous solution of acetic acid. So here in this case, this statement is also false statement. Okay, so it does not contain 12 to 15% aqueous solution of acetic acid. Okay, then comes the functional group of ethanoic acid is a carboxylic group. Now here we know that ethanoic acid means what? Carboxylic acid COH group is present. So that's why yes, it is true. The functional group of ethanoic acid is carboxylic group. Then the chemical bonds in the carbon compounds do not produce ions. Obviously, the chemical bonds, how it will produce ions? It will not produce. So that's why it is a true statement. Here of the fill in the blanks. Now dash is a versatile element that forms the basis for all the living organisms and many of the things we use. The answer is carbon. Carbon is the most versatile element which forms the basis for all the living organisms. That's why we say that in organic compound contains carbon and inorganic compound does not contain carbon. And carbon is present in all the living beings and all the living organisms. Okay, so here carbon is a versatile element. The answer is carbon. Next comes covalent bonds are formed by the dash of electrons between two atoms so that both can achieve a completely filled outermost shell. Now here what happens in covalent bond? Sharing of electrons takes place. Okay, because of the sharing of electrons takes place, so between the two atoms, so both can achieve a completely filled outermost shell. So here the answer will be the sharing of electrons. Then comes the unsaturated hydrocarbons which contain one or more double bonds. They are known as, obviously whenever there is an unsaturated hydrocarbon, that means it contains a multiple bond. It does not contain a single bond but a multiple bond. But here it is said that contain one or more double bond. So in that case, the if triple bond is there, then that will be alkynes. But here double bond it is said, so that means it will be alkenes. Okay. The general formula for the alkyne is CnH2n minus 2, or you can write it as CnHn. Okay. Then a group of organic compound having similar structure and similar chemical properties in which the successive compounds differ by CH2 group is called as, that is known as the homologous series. As we had already studied about the homologous series, so here the blank will be filled with the homologous series where the similar structure and chemical properties will be present between the successive compounds which is differ by CH2 group. Now dash are sweet smelling substances which are used in making perfumes. Now esters, they are the sweet smelling substances. Okay, and they are used in making perfumes here. So ester will be the answer for it. Then various differences can be asked to you. For example, saturated hydrocarbon and unsaturated hydrocarbon. If it is asked that distinguish between them, then what you will write? So in a saturated hydrocarbon, the carbon atoms are linked to each other only by a single covalent bond. Okay. And here in the unsaturated hydrocarbon, however, the valency of the carbon atoms, they are not fully satisfied by the single covalent bond. That's why there are multiple bonds. Then the second point is for the saturated hydrocarbon, they contain only a single bond. Saturated hydrocarbon contain only single bond. But whereas the unsaturated hydrocarbon, they contain double or triple bonds. Then for the saturated hydrocarbon, they are chemically less reactive. Then for unsaturated hydrocarbon, they are chemically more reactive. So one of the true and false in that it was asked that unsaturated hydrocarbons are not more reactive than saturated, but it is more reactive than that of the saturated hydrocarbons. That means saturated hydrocarbons are less reactive than that of the unsaturated hydrocarbons. Then the substitution reaction is a characteristic property of these hydrocarbons. So here substitution reaction is the characteristics properties of these hydrocarbons, whereas addition reaction is the characteristics properties of these hydrocarbons. Now substitution means replacement. So here replacement reaction takes place. Okay, and it is the property characteristics property of the saturated hydrocarbon where replacement takes place. Whereas the addition reaction takes place in the unsaturated hydrocarbon. Now what happens? That if double bond is present, suppose for example CH2 double bond CH2. Now here in this case, if CH3 is present, then there will be a single bond. But if CH2 is present, then there will be a double bond. So this double bond can be removed by adding the hydrogen. So that's why here addition reaction takes place. So whenever you will add hydrogen, then that double bond will be removed. Then in saturated hydrocarbon, the general formula is CnH2n plus 2. This is the formula for the alkene. Okay. But whereas in unsaturated hydrocarbon, which families we consider only the alkenes and the alkynes. So here the formula for the alkenes and the alkynes will be considered, that is CnH2n or CnH2n minus 2. Then comes the difference between the alkane and the alkene. So alkene and alkane. So here alkanes in which the carbon atom are linked to each other by a single bond. Then whereas alkene is linked with a double bond. Then the general formula for the alkane is CnH2n plus 2, whereas the general formula for the alkene is CnH2n. Then alkane, they are chemically less reactive, whereas alkene is more reactive, because as we know that saturated hydrocarbons are less reactive and unsaturated hydrocarbons are more reactive. That's why alkene contains double bond, so it is more reactive as compared to the alkene. The substitution reaction is the characteristics property of alkanes where replacement takes place of different atoms in alkanes. That means in a saturated compound, whereas in unsaturated compound or alkene, addition reaction will take place, and it is the characteristics property of alkenes. Okay. Then there are different scientific reasons. Now ethylene is an unsaturated hydrocarbon. Why? Because ethylene, first of all, ethylene contains double bond between the two carbon atoms. This is the first point. Then the valency of the two carbon atoms, they are not fulfilled by a single covalent bond. That's why they require two more. That's why they require one more bond. Okay, so it is an unsaturated hydrocarbon as it contains double bond between carbon and carbon. So that's why it is an unsaturated hydrocarbon. Then next scientific reason is naphthalene burns with a yellow flame. Now this was asked in one of the true and false. So we will see why it burns with a yellow flame. So naphthalene is an unsaturated compound. Okay, so in unsaturated hydrocarbon, the proportion of carbon is larger. Whenever the compound is unsaturated, whatever the proportion of carbon, it is more than that of the saturated hydrocarbons. So as a result, what happens? Unburned carbon particles are also formed. Some of the carbon particles which cannot be burned, they are also formed. So during the combustion of the unsaturated compound. So in the flame, what happens? These unburned hot carbon particles, they light up and therefore the flame appears yellow. So that's why when naphthalene burns, it burns with an yellow flame. Okay. Then comes the color of an iodide disappears in the reaction of vegetable oil and iodide. Now what happens here? Vegetable oils, they are unsaturated compounds as we know. So it contains a multiple bond as their functional group. So what happens? They undergo the addition reaction. Now as we know that unsaturated compounds, they undergo addition reaction. And vegetable oil is an unsaturated compound. That means it contains double bond. So whenever double bond is present, so naturally substitution reaction will not take place, addition will take place. Addition reaction takes place means what? In that case, if you will add some of the hydrogen, the double bond will be removed. So here in this case, what happens? They undergo addition reaction to form a saturated compound as the product. So the addition reaction of vegetable oil with iodide takes place instantaneously at room temperature. So the color of the iodide disappears in this reaction. So this IDAT test indicates the presence of a multiple bond in the vegetable. In this way we can take the test. Okay. Then few of the definitions can be asked for 2 marks. For example, define the following or explain the following terms can be asked. What do you mean by the alkane? So alkane is an hydrocarbon having the 4 valencies of carbon atoms are satisfied by only single bonds. Okay, so such compounds are known as the alkenes. For example, methane and ethane. Okay, where carbon is attached to 4 different atoms by a single bond. Then what do you mean by the alkene? So alkene is an unsaturated hydrocarbon and alkane is a saturated hydrocarbon. So alkene and alkyne both are unsaturated. So here the unsaturated hydrocarbon containing a carbon-carbon double bond. That means whenever there is a double bond present between a carbon and carbon, in that case it is known as the alkenes. Okay, then what is covalent bond? Or explain the term covalent bond with example. So here the covalent bond is formed by the sharing of 2 valence electrons as we all know. So between the 2 atoms, and it is known as the covalent bond. So now here in this case, 2 hydrogen atoms, they share their electrons with each other to form H2 molecule. One covalent bond is formed between 2 hydrogen atoms by sharing of 2 electrons. Okay. So likewise, sharing of electrons takes place between the 2 hydrogen atoms. Same way, the sharing of electrons takes place between the 2 oxygen atoms. Then sharing of electrons takes place between 2 nitrogen atoms. So depending upon that, they share their electrons and forms the bond. So it forms a whenever there is a sharing of electrons takes place, then that means a covalent bond is formed. Then explain the term structural isomerism with example. So the phenomenon in which the compounds having different structural formula, their structural formula is different, but have the same molecular formula. It is known as the structural isomerism. So butane is represented by 2 different compounds as their structural formula are different. So these 2 different structural formula have the same molecular formula C4H10. For butane C4H10, and we can show it in different structures. Molecular formula will be same, but the structure will be different here. Then explain the term heteroatom in the carbon compounds with example. Hetero means different. So carbon compounds are formed by the formation of bonds of carbon with other elements such as halogen, oxygen, nitrogen and sulfur. So here the atoms of these elements, they substitute 1 or more hydrogen atoms in the hydrocarbon chain. So thereby the tetravalency of carbon is satisfied. Okay, tetravalency means carbon containing 4 valency. That's why it is tetravalency of carbon. So the atom of the element which is substitute for hydrogen is referred to as heteroatom. So here sometimes heteroatoms are not alone, so but exist in the form of certain groups of atoms. So here you can see XX means chlorine, bromine or iodine or the halogen groups. Then oxygen, OH group from alcoholic group O and H. Then simply oxygen group. Then from then nitrogen group from the NH2. Then C double bond O, that is from ketonic group, one of the oxygen. These are all the heteroatoms. Okay. Then few of the short notes can be asked to you. That the compound explain the term functional group with an example. Okay, we have to explain it with the help of example. So the compound acquire specific chemical properties due to these heteroatoms or group of atoms that contain heteroatoms. So irrespective of the length and the nature of the carbon chain in that compound. Few of the compounds, they acquire a specific chemical properties which contain a heteroatom. So therefore, these heteroatoms or the group of atoms, they containing heteroatoms are called as the functional group. So these are all the heteroatoms, they are known as the functional group. So all the organic compounds are derivatives of hydrocarbons. The derivatives are formed by replacing 1 or more hydrogen atoms of hydrocarbon by some other heteroatom or groups of atom containing heteroatoms. So after replacement, a new compound is formed, which has the properties different from the parent hydrocarbon. So for example, for methane, if one hydrogen is replaced by an OH group, then the compound will be methyl alcohol. CH4 is the formula for methane, and if you will replace one of the hydrogen with OH group, then that will be considered as methyl alcohol. Then the OH group is known as the alcoholic functional group here. So few of the functional group list is given to you. Alcoholic group, which is OH group and which can be also called as hydroxy group. Aldehydic group, that is CHO group. Ketonic group, C double bond O group. Carboxylic group, that is COH group. Okay. Then what is meant by the homologous series, and state the two characteristics of the homologous series. Now here in this case, now as we know that though the length of the carbon chain in the carbon compound is different, okay, so their chemical properties are very much similar due to the presence of the same functional group in them. So here the series of the compound which is formed by joining the same functional group in place of a particular hydrogen atom on the chain having sequential increasing length is called as the homologous series. So two adjacent members of the series differ only by CH2 or methylene unit, and their masses differ by 14 units. So here the homologous series of straight chain alkanes can be represented by the general formula, that is CnH2n plus 2. So the members of these series are as follows. For example, it is given methane, ethane, propane, butane, pentane. Okay, so they differ by one of the CH2 unit. Now, as they had said that their masses differ by 14 units, that means CH2 group. Now, the molecular weight of carbon is 12. Okay, and for hydrogen it is 1. So here carbon is 1. So here 12 multiplied by 1, 12 will become, plus hydrogen, molecular weight of hydrogen is 1, and there are two atoms of hydrogen. So 2 into 1, 2 will come. So 12 plus 2, 14 will come. So that's why their masses, they are differ by 14 units. Okay. Then characteristics of homologous series are, while going in an increasing order of length of the carbon chain, one methylene unit, that is CH2, it gets added. Molecular mass increases by 14 units, and here number of carbon atoms increased by 1. So here chemical properties of members of a homologous series show similarity due to the presence of the same functional group in them. So each member of the homologous series can be represented by the same general molecular formula. So while going in an increasing order of the length, there is gradation in the physical properties, that is boiling and melting point. Okay, so likewise different types of short notes can also be asked to you, so you have to answer in this manner. Okay, I hope in this question and answers we had studied few of the short notes, scientific reasons, then true and false, fill in the blanks, MCQs, so that will be helpful for you. And so lastly, thank you all the teachers and my dear students, thank you all. In the next session we will see how to write the IUPAC names, few of the IUPAC names which are asked in the question in the paper, and that we will solve few of the IUPAC names and the common names. Thank you. Ma'am? Ma'am? Hello, ma'am?